Check out these awesome mini flamethrowers. It's a huge flame from a really tiny device. I think it's safe to say that by far these are the most overkill fly swatters I've ever built. So far. And today I'm going to show you how to make your own in this DIY tutorial. To build one of these mini flamethrowers, I recommend picking up a small jet torch similar to this one. I got this at my local AutoZone. You can find these usually at automotive parts stores or hardware stores, and if you don't have either of those nearby, I've linked this exact model in the description so you can follow along and use the same parts if you want to. You're also going to need a butane canister to fill it up. It doesn't really matter what size canister you get, just make sure that it has a fill nozzle that fits your torch. To ignite the flame, we'll use a couple of these old disposable cameras. I got this at my local photo development store. Just type in photo development near me and you can usually find a couple photo labs pretty close by. Just ask those guys if they have any extra disposable cameras for your science experiment, and sometimes they'll give you a few if you ask real nice. Try to get Fujifilm cameras. They have these nice small circuit boards that you can make even smaller by cutting the extra junk off, whereas Kodak and other brands generally have these large circuit boards that have lots of wasted space. So if you have a choice, Fujifilm. First I'll show you how the camera flash igniter was made. Your schematic is going to be slightly different than the one on your screen, but that's not a problem since you're still going to be changing the same components. Let's get rid of the large electrolytic capacitor, but make sure it's discharged first. Let's take the flash lamp off as well. We don't want to damage our pulse transformer when we take this flash unit off, so I'm just going to use a small slotted screwdriver to gently peel that clip off, leaving this terminal behind. We won't be needing these battery clips. We can also remove this shutter switch, which is what the camera uses to fire the flash. Pay attention to where the two terminals are connected, because we're going to use those later in this project. There's one more small change we need to make to the circuitry. Here's our trigger transformer capacitor, and it gets dumped into this pulse transformer to ignite the xenon tube. But there's a current limiting resistor in series with it and the charging supply, and we want to remove that current limiting resistor so we can get the maximum energy into this capacitor, right? And we're just going to bypass it with a jumper. This particular Fujifilm flashboard happens to have a dual contact switch that leaves the trigger circuit disconnected whenever the switch is not pressed. We want to bypass that half of the switch so the trigger circuit is always connected to the power supply. All we're going to do to achieve that is just add a small jumper right across these points here. It's my preference to chop off the extra pieces of circuit board that aren't connected to anything anymore, but be super careful when you're cutting down the board because you don't want to accidentally cut a trace and destroy the entire circuit. For the other side of the switch, I'm just going to connect this small jumper wire that I'll use to connect to an external switch later. To get a slightly hotter spark output, I'm going to replace that trigger transformer capacitor with this 470 nanofarad 300 volt cap I removed from a TV power supply. Try to choose a capacitor like this one between 100 and 500 nanofarads with at least a 300 volt rating. Most capacitors have these three numbers on the front. The first two are the value and the third digit is a multiplier. So this one that says 244 means 240 nanofarads. A 100 nanofarad capacitor would say 104, and a 450 nanofarad capacitor would say 454. The final circuit modification will be to install a spark gap where the old shutter switch used to be. You could use a commercially manufactured spark gap like this with a voltage rating between 300 and 350. Or for the true diehard hacker, you can also make your own. And here's the spark gap I made out of some cut-off resistor leads. You can see just a tiny little gap between these wires. When you first start out, you might find it difficult to adjust the gap and get a consistent spark, but if you continue to play with it for a while, it is possible to get it to fire consistently. I'll finish it up by adding a small white wire to the top of the pulse transformer and to one of the two terminals underneath. It doesn't matter which one of the two you pick. To get a little more power out of our camera flash circuit, we can use a lithium-ion battery like one of these two. This is from an electronic cigarette, and this one is from a toy RC helicopter. You'll have to put a 1 ohm resistor in series with the positive terminal to prevent overcurrenting your circuit. This is just a 1/4 watt, and it's more than enough for this. With the 1 ohm resistor between my lithium-ion battery and the board, it's time to test the circuit. But there's something really important I want to point out. The gap between these two wires is just a little over 1/8 of an inch, or roughly about 4 millimeters. If you open it up much wider than that, you're almost guaranteed to burn out your pulse transformer. Not bad at all. So for the turbo torch, I already used some of the parts in another project, which means I've already pulled all the screws out. But what you'll find inside is this really nice little butane tank with a virtually useless piezo igniter. And the valves on these tanks are all pretty similar. They basically operate by pulling them upwards. Inside this tank is a flow limiter, and we're going to have to remove that. So to get this valve out, I've made this tool out of a slotted screwdriver. You just can see I sliced down the center and I thinned up the sides so that I can grab onto those two spots on the valve head. I should probably mention, make sure that your tank is empty before you take this apart. If you have this torch brand new and you haven't filled it up yet, then great. And our flow limiter is actually all the way up inside this tube. To get this tube off, I'm going to hold the brass head. I'm not going to hold down here because I might damage the threads if the pliers slip, so I'll try to stay far away from those threads and be extra careful. I'm just wiggling these two back and forth and pulling steady pressure away. Alright, and that green thing all the way down inside there, that's the flow limiter that we have to pop out. Finally, okay, it's out. That's all that needed to be done. I'm going to push that tube back on now. And now it can go back inside the tank. I put a little more butane in there just to demonstrate. Now you can see liquid is actually coming out of this thing. That's exactly what we want. In order to open and close the valve on this tank, we'll need some sort of lever that can pivot at that point and basically pull up on that valve when it's pushed down in this direction. I'll use some brass shim stock. It's 1/16 inch thick by about 3/8 across. On the belt sander, I'm going to thin this whole area out from here on back, so from the side it'll only be a 32nd inch thick. Oh, that wasn't supposed to happen. The reason that brass piece broke is because I forgot these extruded bars are extremely hard material and they need to be annealed before you can bend them. I totally forgot to do that. So I'm going to instead attach this small piece of brass and braze that on real quick. Ugh, what a mess. I created a partially square hole in this piece of brass by drilling 4 small holes right next to each other. Now I'm just going to use a file to bore this out until the protrusion coming from the tank can fit straight through this hole. Alright. I decided I'm actually going to take off the rest of this front piece too. This was the first Mini Flamethrower that I put together. And you can see what I did was just use a piece of perf board for the bottom, and that's what's holding all the components up here. But I figured since this is my second go at it, I can make something a little nicer. So I took the back of a flat screen LCD television and took the protective cover off, and it was made of plastic that had this really cool pattern, so I sliced out a bunch of pieces, and I'm going to end up using this with a cutout that I made in it earlier to slip around the tank, just like this. And then these pieces will actually go together like so on here, and you can see how those two side pieces will slide right in. So to begin, let's glue this piece of plastic in place. And now that I have everything lined up, I'm just going to use a little bit of accelerator to kind of speed up the process and lock everything in place. That's looking pretty nice. Before we can mount anything else onto the chassis, we need to install the switch that's going to activate the ignition circuit. I'm going to use this small switch I removed from a flat screen TV, and I'm going to place it directly underneath this lever. By placing the switch there, every time I push down on the lever, it's going to press the switch, and if I continue to push harder, it'll open the valve. So you can see how this action guarantees the ignition circuit will always be on whenever the lever is pushed. I'm going to have to file this piece of plastic down so that the switch is at just the right height. Right about there is where the switch is fully pressed, and that's just about the point where the valve is opening. I want to lock this lever down so that it can't accidentally come off once it's installed. I'm just going to use my soldering iron to melt the plastic right over the top of this plate. In order for this butane to burn effectively, it has to first be in a gaseous state where it can mix with oxygen. But it comes out as a liquid, and that liquid isn't directly flammable. In order to help it get into its gas state faster, I'm going to run it through a brass tube, and the heat from the tube will be transferred into the liquid butane, causing it to turn into a gas. Watch what happens when I just press this tube against the nozzle and give it a 1-second burst. It comes out as a gas. But watch this. Now that the tube has gotten colder, I'm going to give it another 1-second burst, and it comes out as a liquid, because the tube is no longer warm enough to evaporate all of the liquid that's flowing through it. To amend this problem, I'm going to take a slightly larger piece of solid brass bar stock and drill a hole through it that's just about the same diameter as this tube, so I can add some more thermal mass on the outside. First, I have to make the tube wide enough to slip over the nozzle, and right now it's just a little too thin. So I'll anneal it real quick, and I'm just going to heat it to the point where I can see it's significantly changing color. If you can get it glowing, that's great too, because you know for sure you've gotten it hot enough to anneal. Then I'll use a small screwdriver that fits perfectly inside the brass tube to widen it out. I'm just making small circles with the screwdriver. Just about there. Perfect, now it slips right over the top. To make that bend a little easier, I'm just going to insert a piece of solder that's the correct size for the tube. And the goal is to get a 90-degree bend into this piece of tube. And I'm sure I won't be able to pull this whole piece of solder out. Heat it up and melt it out, like I'm going to have to do now. Here's the finished heat sink, or in this case a cold sink. That was just a piece of solid brass tube that I drilled through the center and used a Dremel tool to cut the slots into it while it was spinning. And then you can see that hole really nicely fits this tube. First I have to clean off all this soot from when I heated this tube up. A little bit of tinning flux. I'm just rotating this piece as it slides on so that it guarantees good coverage of the flux over the internal surfaces. The fact that the solder isn't building up on the surface here is telling me that it's getting pulled into the tube. Solder will always flow towards the heat source when it's in its liquid state, so if I heat the front of the tube here more than the back, the solder will eventually get pulled up towards the front. Alright, that looks good. There are several ways we could attach this piece to the output nozzle. We could use a high-strength epoxy between these two joints here, but I'm concerned that the epoxy might start to weaken over time, so I'm going to solder these two pieces together. However, the heat from the soldering iron could damage the valve or melt the plastic that this output nozzle sits in, so I'm just going to take a piece of wet paper towel and try to get it all the way up around that tube so that it can suck up the extra heat that the soldering iron is going to add. And then I'm just going to add a tiny amount of tinning flux to that piece, and just a little bit to the inside of this, but use it really sparingly. Just prepping it with a really tiny amount of solder. It's important to point out here that I'm trying to make sure this valve stem never gets too hot. I'm leaving the soldering iron on for maybe 3 or 4 seconds at the max so that that paper towel has time to transfer the thermal energy out before damage is done. Doesn't get much better than that. And to make sure it's sealed well, I'm going to plug the end of this tube with my finger and squeeze the trigger. And then I'm going to see if I can smell gas at this point here. And you might need to get your nose really close, but if you smell any gas leaking with the end plugged, you probably didn't get a good seal and you need to reheat it. This is a small piece of circuit board I'm going to use to mount the ignition terminals. I just put some electrical tape over these copper areas and threw it in the etching solution, which got rid of the copper between these 2 points. I'm going to super glue it straight to the top, but first I want to rough up this PCB so the super glue really grabs well to it, because I already know it's going to grab onto the plastic pretty strong. I'm also going to apply a drop of accelerator on the back. Putting some accelerator on here ahead of time will help that super glue cure underneath it. I don't think that's going to fall off anytime soon. Now that I've attached the positive and negative leads to the underside of the board, I'm going to go ahead and mount it onto the chassis. I have some hot glue already in place. I'm just heating it up with a soldering iron to get it into a liquid state again. And now that those are in place, I'm just going to make sure that we can still close the case and that nothing is going to be in the way. It's a tight fit, but it does fit together. To finish prepping the case, I'm going to drill 2 small holes through the PCB and the plastic so I can insert the high voltage wires. I'm also going to drill a few holes on the side so I can connect this 3-terminal pin header, and I'll use that for charging later. Then I'll jumper the outer 2 terminals. And detach the charging wires. The outer 2 terminals will become negative, and the center terminal is going to be used for positive. Then I'll also wire up the switch right away. And we can begin to attach all these other wires. And for the discharge terminals, we're going to use these pieces of brass bar that are 1/16 inch thick. They're going to go right on top of that circuit board and be soldered into place. And I want to tin these pads up before I connect the high voltage wires or the discharge terminals. Again, I'm applying more of that tinning flux, and this will really help. I'm not really applying all too much solder, because this flux will make this small amount of solder go really far. Alright, I'm happy with that. So, that gap is just about 4 millimeters if you're wondering. Electrical contact cleaner makes a great flux remover. I'm pretty satisfied with that. And now I'm going to just bend them down towards the nozzle. Wow, geez, there's some power in that circuit. And here's the completed unit. I'll end up gluing the case together later, but for now I want to leave it open so I can still fix things in case something goes wrong. And the question is, does it work? I do my best to provide information that's both factual and functional. I really hope you found this tutorial useful enough that you can duplicate the results, and I'd strongly encourage you to find your own unique solutions to the difficult engineering problems this project presents. I'm sure you have your own unique questions though, so please let me know what they are in the comments below, or just leave me a comment to share your thoughts. If you liked the video and found yourself clicking on that subscribe button, well, I truly appreciate it. Folks, with a project like this, please be responsible and stay safe, and if you don't own a fire extinguisher already, for heaven's sake, go get one. You could literally stop your house from burning down. Be responsible, folks, and I'll catch you in the next video.
Oh, come on, man. When your wires just won't solder together, damn it.
Ow. Hot.
Oh, I finally had it.